All right. What's the difference between velocity and speed?
Velocity has a direction.
Velocity has a direction. Yes, you can read your notes. Good. Velocity includes a vector and a magnitude. So the vector is the directional component. Magnitude is the size of the number. 10 meters per second west is a velocity. 10 meters per second is a speed. It's all magnitude. It's all about how big or small the number is. We start to talk in the next chapter more extensively about the difference between a vector quantity and a scalar quantity. So vector quantities include a direction. These little cars that you see, it's noted, they have the same average speed, but they have different velocities. If you come down Route 7 and you go through the snake curves between Rogers and here, if you maintain an absolutely dead perfect speed of 25 miles per hour, you're creeping through the snake curves. Is your velocity changing? Yes, because every time you change direction, you are changing velocity. You can maintain your speed and still change velocity because you're changing direction. Okay, that's important to remember. Okay, we will start to work a lot, and you already have, with graphical interpretations of velocity. This is kinematic graphing. You created some graphs in this lab, and you can plot. The first and simplest one is plotting position against time, and you did that for both the car and for the marble. If you look at the slope of that line, now it says it in the notes, but what does it give you? What does it say it gives you in the notes? It says it gives you average velocity. Intuitively, you can think about that because average velocity is equal to what? Change in what over change in what? Change in position over change in time. Well, remember slope is change in y over change in x. Guess what's on your y and position time graph? Position. Guess what's on your x? Time. It gives you an equation for average velocity. So let me ask you this. For your cars, where they should, and I realize we did have some, the group who I told you had terrible measurement, I found with the lighter group we did have some problems with the car also, being not completely a constant velocity car. There were some hiccups, so that may have been your problem. If you have an absolutely perfect constant velocity car, what shape should your line take? It should be an absolutely straight line, because the slope of the line is the velocity. If the velocity never changes, the slope never changes. If you have something that is changing velocity, like a marble that's speeding up as it goes, what shape should your line take? We should see a curve, because the slope of the line is the velocity, and the velocity is changing. Okay.